Databases. All right, databases. What is a database? A database is an organized collection of data. It has a range of how much data can be stored on computers. First, I will be talking about database management systems. So, database management systems, usually the acronym is DBMS, are computer software applications that interact with the user, applications, and the database itself to capture and analyze data. Database management systems have been popular since the 1980s. Next, there are three database views. First is the external level, which defines how each group of end users sees the organization of data in the database. A single database can have multiple external views. Second is the conceptual level, which unifies the various external views into compatible global views and provides the synthesis of all external views. Lastly is the internal level, sometimes called the physical level. It is concerned with cost, performance, scalability, and other operational matters. Separating the external, conceptual, and internal levels was a major feature of the relational database model implications that dominated the 21st century database. An example of a database would be Oracle database. Oracle's database is an object relational database management system created by Oracle. This means objects are directly supported in database schisms and allows containers like sets and lists, as well as nested objects. The goal is to bridge the gap between relational databases and the object-oriented modeling techniques used in programming languages like Java. The Oracle database refers to the server-side memory structure of SGA. SGA, called System Global Area, which holds cache information like database buffers and user information. Lastly, the Oracle uses Oracle RAC, or Oracle Real Application Clusters, which are an option that uses multiple instances attached to a central storage array. Next, I'm going to be talking about different types of databases. The first one is in-memory database. This database resides in main memory, but is typically backed by a non-volatile computer data storage. In-memory is faster than disk databases and are so often used when response time is critical. Next, we have active databases, which are event-driven architect, which can respond to conditions both inside and outside the database. Some uses of active databases are security monitoring, alerting, statistics, gathering, and authorization. Next is cloud databases, which are self-explanatory. They are databases that rely on cloud technology and reside in the cloud. Data warehouses are archived data from operational databases and often from external sources like market research firms. They are central source data for use by managers. Data warehouse elements include extracting, analyzing, mining, transforming, loading, and managing data. Navigational databases records and objects are found primarily by following references from other objects. They are associated with the network model and hierarchy model. Okay, let's go on to data storage. Data storage obviously is physically containing materials of the database. Storage puts data into permanent storage and supports specifying which character encoding was used to store data. Data security deals with all various aspects of protecting the database content, which are generally its owners and its users. It deals with controlling who is allowed to access what information in the database. Security can be managed directly on an individual basis or by the assignment of individuals and privileges of groups. Lastly, backing up. Can you back up on databases? A backup operation is usually done occasionally and continuously, so yes, you can. People decide to bring a database back to its previous state, like before an error, so you do not lose that important data you need for your projects or about your company, and so on and so forth. In conclusion, databases seem to have a lot of variety, as I mentioned in this presentation. They seem trustworthy, and they're a great way to store data that a lot of people have. I know in this world, there's more and more data coming in, so we need a place to store all this stuff. So, with all that said, I think databases are great. Thank you so much for watching my presentation.